It would explode and annihilate all of New York City, parts of Connecticut, and New Jersey. This is perhaps one of the best mysteries in our material science. Betelgeuse, a heavenly wonder gracing the night sky, is a popular red, very massive monster star. It got comfortable in the Orion star gathering, amazing stargazers for a very long time. Later, invigoration from famous physicist Michio Kaku raised concerns, proposing that Betelgeuse could have finally exploded. How this impact reshapes our appreciation of heavenly life cycles and the powers forming our universe is a vital question. What ideas does it hold for us? Stay tuned to figure out. Imagine checking out the night sky and perceiving a breathtaking star in the Orion constellation. Betelgeuse, also called Alpha Orionis, is a massive, radiant body at around 5 hours 30 minutes right ascension and 0 declination. It gets its name from the Arabic word Bait al-Jawza meaning the beast's shoulder. In 1603, cosmologist Johann Bayer gave the star its unprecedented name Alpha Orionis, suggesting its status as the most prominent star in the Orion star gathering. Peculiarly, despite being seen as the most incredible in Orion, Betelgeuse holds its name proudly. Betelgeuse is a monster star with a mass several times more massive than our Sun, making it a giant diverged from our planetary gathering. To put it in perspective, if the Sun were a little marble, Betelgeuse would be a gigantic ball. Determining Betelgeuse's distance has been challenging, with measurements placing it somewhere in the range of 500 to 600 light-years from our Sun, a gigantic distance in cosmology. As for magnificence, Betelgeuse shines brightly with an apparent magnitude of around 6. Harvard professor Morgan McLeod noted that Betelgeuse's size and proximity make it one of the few stars that astronomers can closely study using telescopes on Earth and in space. Telescope images reveal Betelgeuse's special features, displaying a surface distinct from our Sun's smooth appearance. Instead of a uniform circle of incredibly hot plasma, Betelgeuse appears as an arrangement of unbalanced foaming gas pockets, some nearly indistinguishable in size from smaller stars. Huge emissions of hot material emerge from Betelgeuse's outer layers, resembling cosmic spring cleaning. One such release is so massive that traveling at the speed of light would require 75 years to cross it. This phenomenon, known as surface mass release, ejects material from Betelgeuse's outer layers similar to the Sun's coronal mass ejections. These releases are not constant but vary in relation to Betelgeuse's internal processes and cycles. At a mere 10 million years old, Betelgeuse is astoundingly energetic compared to our Sun. Despite its youth, Betelgeuse has already burned through much of its hydrogen fuel in its core, entering the later stages of its life as it changes into the red giant stage. During this phase, Betelgeuse uses helium to create carbon through fusion processes, driving rapid, groundbreaking changes energized by its immense initial mass. Scientists propose that Betelgeuse began its journey as a blue-white type star belonging to the largest group of hydrogen-burning main sequence stars. The size of stars directly correlates with their brightness and extreme power. Larger stars, like Betelgeuse, shine more brightly and burn more fiercely. However, this also leads to faster hydrogen consumption and an earlier transition to the red giant stage. Betelgeuse's surface reaches stunning temperatures of up to 89,500 degrees Fahrenheit, a sharp contrast to our Sun's cooler 10,000 degrees Fahrenheit. As Betelgeuse consumed its hydrogen and began fusing helium, its outer layer expanded drastically, making it one of the largest stars known, with a width greater than 700 million miles. Currently, Betelgeuse's surface temperature is around 5,800 degrees Fahrenheit, cooler than the Sun but still vastly brighter, being 7,500 to 12,000 times more luminous. In 1836, astronomer John Herschel noted changes in Betelgeuse's brightness, prompting its classification as a semi-regular variable star with intermittent changes in periodic erratic fluctuations, generally following a multi-day cycle. In 2019, Betelgeuse showed an anomaly, deviating from its typical behavior. Betelgeuse's late behavior caught attention due to surprising fluctuations. Its brightness wavered, following a consistent 400-day pattern, peaking at magnitude 1.3 before dropping to around 2.8. These instabilities were linked to the photosphere, the outermost layer of the star that emits most of its light and heat. Convective movements in the photosphere, where heat moves from the interior to the surface through gases, cause variations in brightness over time. During the fall of 2019, Betelgeuse experienced a massive dimming of about 60%, marking a deviation from its regular pattern. The cause was a huge release of material that formed a vast dust cloud, obscuring our direct view of the star. Although the dust cloud eventually dispersed, Betelgeuse hasn't fully returned to its previous state, and its 400-day brightness cycle has shortened to just 200 days. Betelgeuse's erratic behavior has sparked discussions about the potential for an imminent supernova explosion. In a supernova, as the star burns through its remaining fuel, its core collapses, leading to the formation of a black hole while its outer layers are ejected at speeds of up to 25,000 kilometers per second. If Betelgeuse were to undergo a supernova, it would be a spectacular event visible for weeks, much like the full moon. Given its proximity of just 650 light-years, it would be one of the brightest supernovae ever observed. While star explosions are common, they're usually too distant to be seen without powerful telescopes, making Betelgeuse's potential supernova a major event for skywatchers. As stars age, their cores accumulate iron, eventually triggering a supernova. The most recent supernova observable by the naked eye, SN 1987A, occurred in 1987, about 168,000 light-years away. Though this event was visible to the naked eye and provided significant insights into stellar evolution, its distance from Earth meant it had no major impact on our planet. Betelgeuse, a star at the center of attention, is expected to go supernova, and astronomer Miguel Montero, an expert on Betelgeuse, predicts that its brilliance will rise to that of the full moon when the supernova occurs. Picture a fascinating 2-month period when, on a clear night in a dark city, you could read a book lit by Betelgeuse's supernova. In 2021, Betelgeuse experienced another dimming event similar to the 2019 anomaly, with a 60% decrease in brightness due to a cloud within the star's wind. This cloud obscured part of the star, leading to a missing southern hemisphere in images. After this darkening event, Betelgeuse suddenly brightened, though the cause of the increase remains unclear, leading to further speculation among astronomers. Betelgeuse, now 15 to 20 times the size of the Sun, falls into the category of stars expected to go supernova. Astronomers generally suggest that Betelgeuse could explode within the next 100,000 years. However, a new study by Hayuki Cio and colleagues from Tohoku University proposes that the star might be closer to exploding than previously thought. There are varying opinions on this conclusion. Cio's team bases their hypothesis on Betelgeuse's behavior, consistently expanding and contracting with occasional clues. While they don't foresee an imminent explosion, they suggest it could happen within the next 1,000 years, challenging previous time estimates. The uncertainty surrounding Betelgeuse's timeline has caught the interest of astronomers. However, some scientists argue that stars like Betelgeuse can last for over 10 million years, a remarkably short period for astronomers but still extensive on the cosmic scale. As they search for clues about whether the bright star could become a supernova, astronomers have noted changes in its color. Some describe the star's hue as similar to Saturn's yellowish tint, rather than Mars' reddish color. This raises the question: has the star's color changed? If so, it could indicate rapid development, suggesting a supernova might occur sooner than expected. This color shift offers a clue to the star's changes, helping researchers interpret cosmic events. Whether Betelgeuse undergoes a supernova on time or takes its time to give a glorious display, humanity will have a front-row seat to witness the culmination of one of the most extraordinary cosmic phenomena. What would happen if Betelgeuse went supernova? The possibility of a supernova appearing in our sky has captured people's imaginations. New simulations are helping astronomers understand what we could witness when Betelgeuse eventually explodes, expected within the next 100,000 years. However, uncertainty remains. Betelgeuse is around 500 light-years away, and recent research suggests that for a supernova to have noticeable effects on Earth, the star must be within about 150 light-years. About 8,000 years ago, an event of this nature may have played a role in a mass extinction affecting marine life after the Permian extinction. If a supernova were to happen within 30 light-years of Earth, things could get tricky. Though Betelgeuse's supernova isn't expected to threaten life on Earth, there could still be some environmental effects. The explosion would produce a flood of ultraviolet radiation, potentially causing a brief decrease in the ozone layer. However, research shows that any resulting ozone depletion would likely be minor and short-lived, with limited biological repercussions. Shortly after the explosion, we would detect weightless particles called neutrinos, which are harmless to us. The star would rapidly become brighter, reaching a glow similar to the full moon within weeks. Betelgeuse's brightness would then wane, gracing our skies for about 6 months to a year. As night falls, it would remain a visible display for another 1 to 2 years before fading. Ultimately, Orion would lose its red glow, a shine forever etched in memory. In the aftermath of a supernova, the explosion would generate cosmic rays, high-energy particles that can penetrate Earth's magnetic shield. However, except for the closest supernovae, these amounts would be relatively minor compared to other forms of radiation we encounter. The supernova's final dazzling display wouldn't just mesmerize us. It would also create radioactive iron, a significant mark found in Earth's ocean floor and even on the Moon. This iron, born from a supernova that occurred 2 to 3 million years ago, was only about 300 light-years away from us. Fortunately, its proximity posed no significant threat to life on Earth. Rest assured, such a close supernova is an exceedingly rare event, potentially occurring only once in a billion years. As speculation swirls around the potential appearance of a Betelgeuse supernova, astronomer Andy Howell from the University of California is not satisfied with simple back-of-the-envelope calculations. Seeking precision, he enlisted the help of 2 former graduate students, Jared Goldberg and Evan Forrest. Their complex simulations depict the star's epic finale, incorporating uncertainties while drawing insights from observations of the 1987 supernova, SN 1987A, the closest recorded supernova in modern history. These astronomers concluded that life on Earth would remain unharmed, though the cosmic event would certainly not go unnoticed. According to Goldberg and Forrest's findings, when Betelgeuse ignites, its brilliance will resemble the soft glow of a half-moon, shining about 10 times fainter than the full moon. This entrancing radiance is expected to grace our skies for over 90 days. Recent studies show that Betelgeuse is around 724 light-years away, safely outside the usual risk zone. However, the supernova could have fascinating implications for Earth. Howell notes that many animals rely on the moon for navigation and may be confused by such a bright object. Astronomers themselves would face challenges, as the intense brightness would surpass the capabilities of telescopes and space observatories. To compensate, telescopes would need to capture the subtler, gentler glow of the star. Experts reassure the public that we will have enough warning if Betelgeuse goes supernova during our lifetimes. Earth's instruments would detect signals like neutrinos or gravitational waves generated by the explosion, giving us a heads-up as much as a day before the event. Although this event isn't likely to happen for another 100,000 years, Betelgeuse will eventually go supernova, and the outcome will depend on the materials left behind after the grand finale. As scientists continue to refine their predictions and deepen their understanding of such cosmic phenomena, observations of similar stars at different stages of their evolution provide essential data for modeling the life cycles and potential explosive ends of massive stars. This information helps astronomers assess the frequency and impact of supernovae in our galaxy, contributing to our broader understanding of cosmic events and their implications for both nearby and distant celestial bodies. The study of Betelgeuse and other supergiants also assists in refining the cosmic distance scale. Accurate measurements of such stars' luminosity and behavior help improve our methods for determining distances to far-off galaxies, enhancing our overall mapping of the universe. Moreover, supernovae act as vital probes for understanding the synthesis and distribution of heavy elements like iron and nickel throughout the cosmos, elements critical for the formation of planets and life as we know it. In the meantime, space observatories are closely monitoring Betelgeuse and similar stars, using cutting-edge technology to detect any signs of impending change. These efforts ensure that we are prepared to witness and study one of the most dramatic events in the universe's life cycle, enriching our understanding of the dynamic processes that shape the cosmos. As scientists continue to explore the life cycle of stars like Betelgeuse, they're also delving deeper into the broader processes that govern the universe's evolution. Stellar evolution, including the transformation of massive stars into supernovae, plays a critical role in the synthesis and distribution of the elements that are essential for life. The explosion of a star not only marks its dramatic end, but also disperses these elements throughout space, enriching the interstellar medium and contributing to the formation of new stars, planets, and even life. This process, known as stellar nucleosynthesis, helps ensure that heavier elements like iron, nickel, and gold, key components for the formation of rocky planets and life as we know it, are spread throughout the cosmos. Beyond the immediate impact of a supernova explosion, astronomers are keenly interested in how these events influence the broader structure of galaxies. Supernovae are considered one of the main drivers of galactic evolution, affecting the distribution of matter and even the formation of new stars within a galaxy. The shock waves from a supernova can trigger the collapse of nearby gas clouds, leading to the birth of new stars and planetary systems. This cycle of death and rebirth is one of the most fascinating aspects of stellar life cycles, demonstrating the interconnectedness of cosmic events. Furthermore, studying stars like Betelgeuse provides insights into the physics of extreme environments. The extreme conditions found in the cores of massive stars during their final stages, temperatures and pressures that far exceed anything we experience on Earth, offer a laboratory for understanding high-energy physics, nuclear fusion, and the behavior of matter under immense gravitational forces. These observations can also shed light on the fundamental forces of the universe, including gravity, electromagnetism, and nuclear forces, helping to refine our understanding of the laws that govern everything from the behavior of atoms to the formation of galaxies. While the timeline of Betelgeuse's supernova remains uncertain, the ongoing research into its behavior and eventual demise underscores the importance of continued observation and exploration. The legacy of such stars not only expands our knowledge of stellar processes but also contributes to the grander narrative of the universe's evolution, from the first atoms to the formation of life and everything in between.